Hello, I'm JW. Today I'm looking at that solder pot thing again, and as in the previous video we've mostly taken it apart and seen what's inside. So this time we're actually going to see if we can get the thing to actually work, and of course put it back together in the way it may well have been intended to be in the first place. Now here's the solder pot thing itself, and we saw the middle of this in the previous video, and it's still in its sort of mostly dismantled state. And the back plate here, feet and the knob there, which we'll just place in here for a moment. And other things we have aside from the piece itself, we've got some heat shrink sleeving, a mains plug, 3 amp fuse inside, and some mains flex. This is 0.75 square millimeters, 3 core, and this is heat resistant PVC, so rated up to 90 degrees centigrade, so we'll be obviously fitting those to the item a bit later. And before that, what we need to do is to make a bit of adjustment here and cut away and move some of the components inside. So what we'll start with is just cutting off the wires here, so we can actually get the circuit board out, and we'll also just go in here and cut off the wires to the fuse holder as well. And as we saw previously, this flex here doesn't fit particularly well in the fixing there, so again we'll just cut off that white tie on the inside as well. And then we can just pull the flex out. Now the wires go over to the switch here, so let's just cut those out as well. And the rather poor earth tag, and then we can just take the flex completely out of there. So there's the plug there, and of course the flex, sort of the right colours, although not quite right. And then we're left with the basic equipment here. We've got the little circuit board, which as we saw previously has been wired up just to bypass the circuits completely, and the switch at the bottom there, and just that little fuse holder. Now the switch here, we'll just remove this as well and just trim off the wires to that. Now this is the circuit board which you saw previously, and of course as several comments actually said, if someone had put the fuse in here then it would have avoided this problem completely, but essentially what they've done is just connected the input to the output directly, which of course is no good. And the triac here, which is the main thing which switches the output and also controls the actual power there. Basically it's the 2 pins here, so the actual load and the input should be connected between the 2 pins, so it would be this one here and the one we have. And of course if the fuse had been fitted, then it would have actually been this one with the fuse bridging across the 2 there as on the top. But say the fuse is not installed, but yet they did fit the fuse in the case, which is somewhat odd. And the little blue one here was actually a diac, as the symbol underneath does show, so it looked like a diode on that position we had it before, but bend that away, it's a diac which is used to trigger the triac there. So we'll take out these wires here, we'll leave the one heater connected in here, so I've just trimmed off the back there because it was ridiculously long, and then this should work as originally intended. Now while the soldering iron heats up, inside the case here we've got what's supposed to be the earth connection here, and it's attached to this very thin piece of metal in the middle, so we'll just remove that completely because we're not going to be using that. So they have made a bit of an effort there, but sadly, as you can see, they didn't remove any of the paint from the screw piece, and this is an incredibly thin bit of metal. It's just basically a separator between the heating part and the compartment with the control in. So it may have cut in by the thread there, but pretty unreliable kind of connection altogether. So we'll just stick that back into position there and just bend in the metal back where it started from. Now these are actually the line inputs here, which we don't particularly want because, as we saw before, it just basically goes straight over to the heater. So we'll take these wires out. So we can hopefully melt the back and just remove those. So they're gone. And say what we should do then is connect to one of the pads over here, which will go to the centre pin, and then the output is on the pin on the end there, and then the gate or the control is that side. So assuming the other components are functional, no particular reason why they shouldn't be, this should then work. Now let's just have a look at the plug here. This is just a normal UK plug, 3 amp fuse inside, and you can actually buy these with the 3 amp fuse included, which is far more useful than the 13 variety, because the vast majority of stuff simply does not need a 13 amp fuse. So just remove that label there, which is now torn and left a residue there, and so you've got the red 3 amp fuse inside. So we'll take our 3-core flex and just connect that to the plug. So that's the plug there, fully wired up, so the 3 conductors and the 3 amp fuse it was supplied with, and the flex grip here at the bottom. So I just need to put the lid on there and just fix the screw in the middle. Now it's worth mentioning with these things that if you are going to assemble these, or even if you can actually buy plugs with the moulded on variety and then just a length of wire, it's very important not to leave these things just laying around, because if someone got hold of this, as in a child or something, plugged it in, then of course this end is therefore live and could kill whoever touched it, and obviously you don't want that to be happening. So if you're going to make these things up, either make them up and then use them straight away as we're doing here, or keep them securely locked away. Now the other end of the wire, we just need to strip some of the insulation there, and we're going to strip off a fair amount of this end. So standard colours there, green and yellow for the earth, blue neutral and brown for line. Now in the box here we do have this inline fuse, which say had that little glass fuse in there, and in this case we're not actually going to use this because being in the UK we already have the fuse in the plug here. But if you were going to do something that's in another country, then you would need to include the fuse, because obviously most other countries do not have fuses in the actual plug. So that would be needed, but say because we're in the UK, all the plugs have fuses in, so we're not actually going to use the fuse holder in this case. So we'll just dispose of that. Now what we need to do is just remove this flex thing from the panel. That's just pressing the middle down and easing the thing through the front. So just a standard 2-part grip there, so flex goes in the middle and then the other piece just presses over the top and holds the flex in position. So we will be reusing this, but obviously with the decent flex rather than that rather doubtful stuff which was used previously. So just need to thread that through the hole. So that's that back in position, and this is slightly larger diameter than that black variety we had before, so see now it actually holds the flex decently securely, whereas before they actually used that silly little bit of cable tie in an attempt to secure it. Now for the earth connection, rather than trying to attach this flimsy bit of metal here, I'm just going to connect to one of the screws here, which is much more substantial. That piece is considerably thicker there, and those screws also go into the bottom of the metal solder pot itself, and after the heating elements around the side, so any fault there is obviously connected directly onto the metal piece here rather than just some flimsy painted panel at the bottom. I'm going to use one of these ring terminals here, single hole in the crimp end, so we just need to strip off an appropriate length of the wire here. Just twist those up there, place the terminal over, and then we'll just crimp that in place with the appropriate tool. So that's crimped on there, and we'll just undo one of these screws. So there we have just the metal cleaned up and completely bare, so I can now place the screw through there and of course into the threaded part underneath. Now here's the other connections, and it's got the neutral coming in here, so that's just from the mains lead, and that just goes straight through to the heating element here. And I've just twisted the two ends together, put a bit of solder over and some heat shrink here for later use, because we also need to connect this to the switch here so that the little neon inside will light up when the switch is in the on position. So that will go to the side here, and the switch contacts are actually these two, so we're going to have the line coming in onto this one, and again a little sleeving just to put over that afterwards. And I've got this other piece of wire here which we'll just do to the middle terminal, which is the switched output, and that will come across to the little circuit board here. And we've already got the heater other side attached to that before, and obviously we're just going to put this through the appropriate hole on the top there, which in this case will be up this end here, so it actually goes to the centre pin there, and obviously the rest of the circuitry there. And then of course the output is the other pin there at the top. That's already connected to the heater output. So that's that all soldered together. So basically we've got line coming in on this one here, and then via the circuitry there, and then going out again on that one which was already connected previously. So the little nut there will just go through the hole into the casing, but before we do that I just want to remove some of the paint from around the hole there, so we make sure that this metal spindle is actually in contact with the case, which again is connected to the earth, which we saw before. Now the board here, as you can see, has a very thin edge here, so there's not a lot of clearance between the edge of the board here and the actual metal, which although it's painted, it's not really very good. So what we'll do is take a piece of this tape and we'll just place this across the bottom here, so that the edge of the board basically rests on the tape there. So just cut that to appropriate size. Now, so these pads don't actually come up to the edge of the board at all, but given the fact there's a very limited distance between the solder pads and the metal there, just put that tape there too. It doesn't sort of arc across to the casing. So all that remains then is just to place that through the hole, and just sort of get that lined up as best as we can. And then on this side, just this little nut goes over the top there just to secure it in position, and then we'll just tighten that up with the pliers there. Now this is the rear cover, and as someone else in the comments said, the holes in this do seem rather large. It's not too bad because I mean this end is all basically earth metal underneath, and you've got the double insulated wires there. This end they could be somewhat smaller, but ultimately there's not a lot we can do other than block them up, but obviously that would then restrict the amount of heat or ventilation that would go through there. So anyway, that will fit over the top there. I mean, in theory, if you've got a wire or something and poked it in here, you could come into contact with live parts, but obviously you have to be fairly careless to actually do that. So we'll just bend these wires in place, and then we can put the lid obviously over the top, and I'll just place the feet and the little screws into the holes at each corner. So all back together then with the just feet holding on the back plate, and so you can see the wires there, but they're all insulated and the board is sideways, but theoretically if you shoved some object in there you could possibly contact the live parts. But let's now find out if it actually works. Now the knob here we just need to replace on the spindle here, so if we turn it to the minimum we can use the end of the arrow there as some kind of indicating point. So we just position that there, and that should go around to the other mark, which is fine. So push that on fully, and we've got our little on and off switch here. Now I just need to do a couple of basic checks before we use the other machine. Continuity, we should of course have continuity between the earth pin of the plug and the case, which we do. So as you can see there, the whole case is pretty much connected. And if we go down to the back, we can again just check with those screws as well and the metal inside, and in fact the entire thing. So that's fine, that's what we would expect. And just make sure we haven't done something blindingly unobvious, just make sure we don't have continuity between the other pins and of course the metal parts of the case either, and likewise for the neutral as well. So that seems all good, so that's certainly a reasonable start. Now for the other test we use the machine up on the shelf there, so you have seen that in previous videos, so we'll just clamp on say to the pot itself. That would seem sensible. Just put the wire main lead into the plug hole on the front, and as we've seen in other videos, this will test that the earth is properly connected, so using a sort of 20 odd amp current there, and also make sure that they by putting 500 volts or so between the conductors and earth, there's no obvious short circuits or whatever as well. So try that, making sure the switch is in the on position. And that's fine, that's easily a pass there. We'll just try it with the off position also, that shouldn't make the slightest difference, but as before, that is a pass as well. Now I just wedged it up on the shelf here so we can see this final part, and I've got the switch in the on position plugged in the front here, and this meter here can actually show the current that the appliance is using while it's in operation. So by pressing these buttons we can power it up. We should see the little red light come on, and then we can turn the knob here and we should see the current being varied on the meter. So if we press the button, so we've got the red light on, and again if we turn that off we can see that will go off. So in the off position with 0, if we turn on, you see the current will actually move up there to a modest level, and then if we turn the knob we should see the current basically increases and of course decreases back down. So that does seem to be working as expected, and at the top there we're about here on the scale, which is sort of 5, 6, 7, 8. So that's around 0.8 amps being drawn there, which seems reasonable for the wattage that was given. And if we go down to the minimum, then again we're talking about sort of 0.2 amps there, 200 milliamps or something, which again is reasonable enough. Now obviously I'll lift this horrible mains lead with that weird plug on the end there, and a comment was put there by Mike's Electric Stuff, who suggested this cable is probably not going to be 0.5 square millimeters. And quite right, because the inside is that weird, really thin stranded stuff, which is probably aluminium with a copper covering on it. It's sort of coppery coloured, but nevertheless extremely thin. And the insulation is that sort of not quite right stuff, where it's fairly flexible, but it's got a sort of a brittle type of quality. When you scratch it, it sort of goes white on the outside. So definitely not an approved type of flex there. And obviously this plug is some Chinese thing which may or may not be valid in whichever country it came from. And the wiring actually is correct. So the brown one, or the sort of reddish brown one, does go to the line pin, and the blue does go to the neutral. But the earth, as we saw before, that doesn't really connect very well with a pin. So at a later time we'll test it outside and see if it sets on fire or whatever. So finally then we'll just see if this thing does actually melt solder, which of course is the whole point of having it in the first place. So we'll plug it in and heat it up and put some solder in. Now if you're going to use a solder pot, it's not a good idea to use solder as in the stuff you get on a little roll, because of course you'd be feeding that wire in there for 50 years. So what you do is get solder in a bar form like this, or you can buy sort of pellets as well. And it's important to get solder which does not have flux inside. Now if you buy solder like on that roll, it has a core of flux inside, and that's why you see this smoke sort of burning off when you actually use it. But of course if you use that in a thing like this, as soon as you put the stuff in there you'd have massive clouds of flux burning off for goodness knows how long, and obviously that's most undesirable. So just get some solid bar solder, and obviously no flux in that at all, so you can just melt it down and it doesn't set the place on fire and have smoke coming out. This one is lead free, so it's just stamped there with the various markings to indicate the metal content, SN for tin primarily, with a bit of copper bunged in for good measure. So we've got the pot here, and obviously we'll switch on. We've seen that obviously works previously, and then put the bar on here and see if it melts. Now we'll leave it on the minimum setting to start with, see if anything actually goes, but I think the reality is we'll probably have to turn it up at least to get it going. So let's wait around and see what happens, if anything. You can certainly feel some heat coming off of the thing, so definitely it's heating up. Now it said in the manual it would take several minutes to actually heat, so obviously we don't expect it to melt straight away, but so you can certainly feel that there's heat coming off of the thing, so it is obviously heating up. Okay, we can see now it is actually starting to melt the solder, so that's fairly promising. It's been on for just under 3 minutes so far, so that's a reasonably promising start. And I say you would expect it to take a while to actually heat the stuff up, because obviously it's got to heat the metal can first before the solder itself. But as you can see there, it is now melting this solder in there. And I say we do have the temperature set to maximum at the moment, which obviously we'll get it heating fairly quickly. Now just point out this is lead-free solder, so it may look a bit weird on the top with that sort of frosted effect which lead-free solder tends to have. rather than the lead variety, which obviously looks a lot more smooth and decent when the joints are formed. But yeah, it seems to be doing the job okay. Okay, so I've melted sort of just over half of that stick into the vat there, and you see it's certainly melting that no problem. Now I've just turned the temperature down, actually turn down to the minimum setting, and see if it actually will keep the stuff actually molten, because you don't necessarily want to be running it at the full power all the time, as that obviously could cause it to be overheated. And if you remember from the other video, the instructions did actually say not to run it at point above 6, because it could get too hot and cause some kind of accident or whatever. So we'll leave it on the minimum setting and come back in a few minutes time and see if it actually is still molten in there. Obviously if it is, then that's fine, but if not, then that's going to be a bit of a fail. Now I've had this on for about 15 minutes and it is still molten. I've just changed the connection over to connect to this meter so we can see the power consumption. But yeah, the solder is still totally molten in there, so we can put plenty on the end of those horrible old wires. Not the recommended way to do it, but nevertheless still perfectly molten and completely usable. And so that's on the minimum setting here, which claims to be about 200 centigrade, but of course we can probably ignore that because it's not actually a temperature controller, it's just the power going in. And we can see here on the meter here, it's using about 45 watts on the minimum setting. Voltage here is about 245 at the moment. Power factor of just under 0.5, as you would expect due to the phase cut kind of arrangement. And if we turn up the power here, you can see it will increase on the display there. And at maximum, it's actually around 205 watts, power factor of 1, of course, because it's basically just a heater directly on the mains. So 204, 203 or something, a lot more than the claimed 150 watts rating of the device, but nevertheless, best probably have a bit more than not enough. And also bearing in mind this is rated at 220 volts rather than the 245 which we have here. But yeah, certainly at the minimum setting, using about sort of 44 watts or so, and keeps the solder perfectly molten and usable in there. And so that's lead-free solder, so that has a bit of a higher temperature melting point than the leaded variety. So if you use it with the lead type, again, it wouldn't be a problem. So that's it for this video. And next time, or some other time, we'll have a look at this cable again and maybe burn that outside. But until next time, thanks for watching.